As somebody who's working in the clinical domain, I am always on the lookout for open source models in the clinical space. So this is MediFi-Instruct from Microsoft. So this is a 3.8 billion parameter large language model or a small language model, which can perform various tasks related to clinical natural language processing. So this model uses research which require medically adapted. It's useful for research which requires medically adapted language models, memory or compute constrained environments, latency bound scenarios. So this model is designed to accelerate research on language models in medical and clinical scenarios. And they say that it should be used for research purposes as with other small language models which have been released in the medical domain. So we can try out this particular model in a Colab notebook. That's what I'm going to do. But before that, this model, how did they create this? These models are actually fine-tuned from a base Phi 3.5 mini instruct model, and they fine-tuned it in the medical and clinical domains. That is what they did over here. So this particular 5 MediPhi experts are fine-tuned on various medical corpora like PubMed commercial, medical Wikipedia, medical guidelines, medical coding, and open source clinical documents, and merged back in their base model using SLERP method to conserve general abilities. So that is what they are saying over here. So one model combined all 5 experts into one general expert with the multi-model merging BreadCrumbs. So that is how they have created this Microsoft final expert model, which is MediFi-Instruct. So we can, they have also released a paper, so we can look into the paper as well in a later video if required. What they are saying is that they've also built the MediFlow collection, which is a synthetic dataset of 2.5 million high quality instructions on 14 medical NLP tasks, 98 fine-grained document types and JSON format support. So here they are talking about the performance of this model, saying that it is 64.3% on medical entities, 49.5% on radiology reports, and 44% on ICD-10 coding on a particular clue benchmark. That is what they're saying over here. So they have created a new clue plus benchmark, which is for clinical tasks. Okay. So we can try out this particular small language medical model in Colab. So let's do that. So what we require over here is that we have to add a secret for Hugging Face, tokens over here. So I've created an Hugging Face token secret over here, and I've copied the access token from Hugging Face over here. So that is required over here. So this is a T4 instance. So you have close to 15 GB of GPU RAM. The model itself takes around 8 GB of GPU RAM, and when I'm doing multiple inferences, if you see, the memory usage increases over here. So to instantiate the model, all we need to import auto model for causal LM and auto tokenizer and pipeline from transformers. We can use the pipeline to generate inference over here. So this is the model name, Microsoft MediFi-Instruct. You can instantiate the model like this: auto model for causal LM from pre-trained, model name, device map, and all those stuff. The tokenizer is also from the same model. So here is our prompt. So this is an operative report note. So operative report performed this particular operation, which is cholecystectomy. Okay. And operative findings are this: the gallbladder contained multiple stones, thickening. There is some operating findings over here. So you can create the messages like this. So this is the system prompt: extract medical keywords from this operative notes, focus on anatomical, pathological, or procedural vocabulary. The prompt is this particular text. Here is your pipeline text generation, where model is model, which you have instantiated in tokenizer. And here is how these are the generation args, where you are saying is maximum new tokens is 500, return full text is false, temperature is this, do sample. And here is how you can generate the output. Output is equal to pipe, messages, and generation arguments. So when you run this particular model, you need to provide access to the HF token. So once you give the secret HF token access, it will download the models, and it actually does inference. And if you see over here, it has extracted the required information over here, like the anatomy and other stuff over here based on our prompt: anatomy, pathological, or procedural vocabulary. So it is the anatomy is gallbladder. This was the procedure, right? And what are the findings? So I wanted it to try out on other text also. So what I did was I pulled out some kind of a nursing note over here, right? So this is a nursing note which I pulled from Mimic dataset. So this is a 50-year-old female admitted in transfer from, this is a ICU note or cardiac critical unit or that kind of a nursing note. So I gave this note and I said extract clinical diagnosis symptom from the clinical note and code them using ICD-10 codes. What is the primary diagnosis and treatment plan? So that is what I wanted to inference over here. Basically this prompt, and I can actually generate that output over here, which is what I've done. So it has pulled out that the primary diagnosis hypertensive crisis. This is the ICD code for that. Secondary diagnosis is hyperkalemia, and this is the what you call ICD-10 code. And the treatment plan is dopamine tapered, vitamin K administered, fluid bolus given, monitor blood pressure. Okay, so if you go over here in this particular text, in the end over here you will see that that particular treatment details will be present over here, what was done and stuff like that. So if you go a little bit over here, you can actually see that particular treatment being given to the patient. So NS fluid bolus given with improvement in dopamine taper, then DC, right? So it pulls that information properly, and here you have this, and mental status changes post-fall at home and continued hypotension. So this is a hypertensive crisis. So it has done that extraction properly over here, and it is presented the output basically. So you are extracting this particular information and ICD-10 codes also. Okay. Now I tried one more discharge summary, basically a slightly longer prompt over here. Right. So again, I gave this particular discharge summary over here. And I asked the model to actually, here I said extract clinical diagnosis symptoms from clinical node and code them using what is the primary diagnosis and treatment plan again. So here also it is saying that the primary diagnosis is traumatic brain injury, which is correct according to the text. Symptoms are these things: weakness in leg, fall with head injury, and so on. Treatment plan is this, right? Kind of repeats the same thing again over here in the text. That is what I have seen. You get the output twice over here of the same thing. So something to do with the prompt over here. Like if you put the prompt correctly, it will generate the output properly. Okay. Another discharge summary which I tried over here was extract clinical diagnosis symptoms from the clinical note, code them using ICD-10 codes. What is the primary? Create a care plan post discharge for a particular discharge summary. That is what I tried over here. So here, if you see, it is again, primary diagnosis is coronary artery disease. This is the ICD-10 code. Secondary diagnosis is hypertension, hyperlipidemia, hepatitis, tuberculosis, so on. It has pulled from the history. Then there is this treatment plan, okay, which they have given. And here is the care plan post-discharge. Monitor blood pressures, adhere to medication regimen, attend all follow-up appointments, maintain a heart healthy diet. So these are some kind of a post-discharge care plan. So it has actually been able to generate this. I again gave this thing like extract and codify. Okay, there is a typo over here. So I said extract and codify all information required for an insurance claim. And I generated the output. Because it is 500 tokens, it is actually generating a summary over here. So what I'll do is that I'll copy the generation parameters. Okay. And let me increase max new tokens to at least some 2000 or something like that. I'll copy that over here. And let me increase the tokens to say 1000 or more. Okay. Let's run this again. Okay. So let's run this again. This will take some time to generate, and let's see the results. So when I tried to generate for say 1024 tokens, it kind of went out of memory over here. So let me restart the session and then try it again. Okay, so the model has been loaded now. Now let's instantiate our prompt. Okay, so this is the discharge summary. Here the prompt is extract and codify all information required for an insurance claim within 500 tokens. Let's now instantiate our pipeline and do the inference. Let's wait for the results. So it has done the inference over here, and it is actually created a note for the insurance claim, right? Attending physician, chief complaints, major procedure, history of special illness, past medical, this thing. It has done that over here. So it is good that now we have another small language model for clinical data processing or medical data processing for clinical NLP. So you can go and check out this particular model, and hope this video is useful to you. See you in another video.